or started shifting from large computers to mini-sized computers. And these mini-sized computers, when they came into existence, they were mainly used for or to run control applications. They were basically termed as controllers. So you feed your program and they control some operation. And very good examples are in these petroleum refineries, where you have so many signals coming into a computer system from various sensors. And you want to process these signals, we call them live signals, that are coming to the hardware resources, of course, from various signals, or what we call transducers. So they are fed into the system, and then the processor carry out some decision making based on the input it's getting from the sensors. And we are busy applying them today, even today. For example, in traffic lights, assume you have a roundabout and you have two inlets or two roads that come into the roundabout, and the two are leaving the roundabout. And of course, you need to monitor what we call the number of vehicles in specific roads, and of course allow them to proceed to wherever they are going, depending on the traffic in some specific road. That is one of them, and another one is in the in agriculture, where you want to monitor the soil pH and the soil moisture and things like that, and you relay that information to some computers, some small computers, where you either turn on the pump or you don't turn on the pump. So still the concept of control application or a process control is still being used, of course, using not mini-sized computers, but what we call as microcontrollers nowadays. But that was the advent of process control. So here you receive signals from sensors, and then you make a decision, or the processor makes a decision on what is supposed to be done. And then when the engineers saw that computers could run process or control applications very well, then they developed what we call as real-time processing. Rather than reading the live signals, processing them, or making some decisions, they will now send back some information. So remember, with the process control, there is no feedback. So you just receive live signals, make a decision. But with real-time processing, you receive the signals from the sensors, process, make a decision, and then send back an information. And of course, currently, we are talking about distributed processing or distributed systems, because now the hardware is no longer centralized, but rather distributed, maybe over the internet or over a local area network and things like that. So distributed processing has come up as a result of computers networked and resources networked, rather than being centralized. And of course, we have networked systems. I've talked of the internet. And now people are trying to develop what we call a network operating system. Maybe they are in existence. So that's what I wanted to discuss. It was a few notes, but having some concepts, some good concepts there about the various processing that we have. Any question before I proceed to programming? I want to do a little bit of programming today, advance from where we stopped yesterday. Any question? Any question, class? Okay, very good then. Let's proceed to programming. So you can add more flesh to those notes. You can read more on the various processing that we have currently, and you can even shed more light. I might have not covered all of them, but read ahead, read and research more. Read and research more. Okay, so later on, or last week, I told you to install code blocks, and I'm sure majority, if not all, have installed the code blocks, and you are running the console applications. And you are running the console applications. So I want us to go through that Casimbo example that we did. Our first C+ program. Our first C+ program. You can open your Windows, your code blocks. As you can see from my window, let me see how I can try. It's very tiny. You can see my screen. Class, can you be able to see my screen?
Yes, we can.
So you can see I've highlighted the first line, include IOStream. We have been talking about the various computer resources. We talk about the hardware, that is the CPU, the memory, and the input-output devices. So when this file here, it's a file you are including to your program. The way C++ is designed, the first thing is there are those standard files that come with the compiler or the IDE. When you install the IDE, they just come with the IDE. So you don't need to rewrite. I remember we talked about a library of functions, and we said those ones, if they have been developed, you don't need to rewrite them again. So you just include them in your program, and then you use them. So any programming language has a library or has a dictionary. They have a dictionary and they have what we call libraries. So the IO stream is the input-output stream. It is the header file, or it's part of those libraries that we are saying that helps your program to use the input-output hardware resources. The #include IOStream, what it does, what this file does, it's called an header file. It's called an header file. That's how you comment, header file. It's an header file that includes a file that will.
Hello, excuse me, sir.
Yes.
I'm asking, after clicking console application, where do you go again?
My friend, I thought you did this one last time.
You know, some of us were left actually to be assisted by our friends, but they didn't.
My friend, it's a whole week, is it? That one I cannot discuss right now. That one I can't discuss now. Now you are taking me back. I'm sorry, I can't do that right now. So I'm saying I should include IOStream. It's an header file. Actually, it's a standard header file. We'll come to that later on. Standard header file that includes files. Let me call them files that will enable your program interact with input and the output hardware resources. Up to that point, am I clear? So you can see input output stream. So it enables whatever that you are going to either input from the keyboard or print to the screen to function well. So it incorporates the monitor or the screen source file and the keyboard. So you can be able, once you include the IOStream, you can be able to type some things to your program, or you can print some things to your program. Any C++ program must have one int main. Let me start there. Any C++ program must, underline that, must have only one main function. And this main function is the entry point, which is the entry point, your program. So the first, when we are compiling our code, the entry point to start compiling our code is the int main. So the compiler, the GCC GNU compiler, will look for this function in your source code. You can have so many functions, but the entry point, the first program to be compiled or called by the GCC GNU compiler is the int main. And you should have one, not two, not three, because if you have two or three, you will confuse the compiler. You only need one entry point. So you need one main function, not two, not three, just one. And then there is this keyword int. Int is the short form for integer. So a function, the format for a function is the return type, the name of the function, and then the parameters. You put them in the brackets. The return type comes first, the name of the function, then the brackets hold the parameters. So our int main function will return an integer. Int is the short form for integer. I know you know integers. And look at what this function is returning. It's returning 0. And I will tell you where it's returning this 0 to. So 0 is an integer. So integer, short form for integer. You cannot have an integer here and then you do 0.0. It will conflict. What you are returning in the body is a float or a decimal point, but what you have declared int main to return is an integer. So this will bring an error. So it has to be an integer 0. 0.0 is not an integer, it's a float. Up to that point, class, am I clear? Clear? Am I clear?
Yes.
So there is these two curly brackets. They carry or they hold or they enclose what the function does. For example, our int main is only doing one major thing here, sending out the string hello world the string hello world to the screen. That is what it is doing. We said cout is a function that will carry out whatever is in these brackets and send them to the screen, to the console. So to send anything in C++ to the screen, you just write cout followed by this left. Is it arrows? Are they called arrows? How do you call them? Class, how did you find their call? Class? Anybody? Are they called? Class? Adrian Bates. Adrian? Adrian?
Yes.
How are they called?
Not sure.
You find out. You can't be told everything. So when you are sending out to the screen, you use this kind of, I don't know what they are called. You find out. And you send, so this one is sending to the screen, Somebody is telling me they are called angle brackets. Okay, angle brackets, very good. So they're facing leftward. So leftward means you are sending to the screen. And if you are reading, we'll come to that, you will send to, you will use the right angle brackets. So you can also put and then there is the end line. This means once you have printed this, put the cursor in the next line. Put the cursor in the next line. Put the cursor in the next line. So print to the screen, and on the screen, put the cursor on the next line. So you can also write your name, hello world, and then you can say, you can even modify it, say cout. This is my first C++ program, and then you put end line like that. So if you build, keep looking at these logs and others window down here and check if there are errors. If there are no errors, now you can run. So you can see my screen, I've printed hello world, and because I put the cursor in the second line, I have printed, this is my first C++ program. Look at where the cursor is blinking. It's in the next line, in the next line. So any language, for example, English, we have a dictionary. Kiswahili, we have kamusi. So any language has a dictionary. The same case to programming languages, they have their own dictionaries. And their dictionaries are termed as namespaces. Namespaces, 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 namespaces. For example, the namespace standard or the dictionary standard has the definitions of cout and this kind of these left angle brackets, end line, return. All of those ones are defined in this dictionary or a namespace called std. So we are saying include this header file, and we're going to use this dictionary called std. And in programming language, they are called namespace. They are called namespace. So any questions so far, class? Any question? Any questions so far? Programming is not easy. You have to find good and enough time to keep practicing. Or somebody, they're saying they are known as operator. Ishmael, you are asking, can we create another function called main function with a void return type? It is, yes, you can put void here, but I will come to that. So if you are doing void, then here you don't return. So if it is void, you don't return. But there is very good reason why we do int and not void. Void means you are not returning anything. I told you in a computer system, you have hardware. Then the hardware, on top of the hardware, you have the operating system. And then you have now your application. Whatever we have developed here is a simple console application. So the console application we have developed communicates with the hardware through the operating system. This console application we have developed communicates or utilizes the hardware resources through the operating system. For example, mine, I'm using Windows 10. We need this return 0. The return 0 is the only way our main function will communicate with the operating system. So it means the return 0 means once you have completed, or once the main function, let me put it that way, once the main function completes its task, it returns once the main function completes, it returns the time slot it was allocated, it returns the time slot it was allocated by the operating system, by the operating system by sending an integer 0. So that's the only way our program will communicate with the operating system, that it has the session it was given, it has completed its task, it needs to return its the time slot back to the operating system. I don't know if I'm clear. Ishmael?
Yeah.
Am I clear?
No, I was asking that, I mean, after creating the main function, can you create another function called main, or
Another function called main?
with a different...
There is something called function overloading.
Yeah.
We'll come to that later on, but with C++, it's better to create a different name rather than main. Main is the entry point of C++ program, C and C++ program. So it's better, yes, you can create other functions, but give them different names. You don't confuse the compiler. That is okay. I don't know how other programmers do it, but that's how I do mine. I don't use the keyword main. I don't use this main name. I give it a different name. Am I clear?
Yes.
Yeah, but use a different name. Use a different name. Main is the entry point of a C++ program. So you better retain one main function and create other function, because we are not limited to function names. We can create as many functions as possible. As many functions as possible. So I'm giving 2 tasks today pertaining programming. The first task, you can write down. The first task, I want you to, number 1, tell the user to enter some sentence. The first task, tell the user what your program should do. Should tell the user to enter some sentence, and then your program should be able to print the entered sentence. Remember, here we are just printing what we have predefined within the int main. But I want you to modify this. You tell the user to enter some sentence, and then you print what the user has entered to the screen. Then number 2, assignment number 2. So assignment number 1 is you write a program that prompts the user to enter a sentence, and then the program prints the entered sentence to the screen. Number 2, or assignment number 2, you write a program that creates a diamond shape, using asterisks. Asterisks, I know you know them. You can search that. You have the asterisk in your keyboard. It is above, on my keyboard, it's above letter 8 or number 8. It's above number 8, asterisk. Asterisk symbol. So it is this symbol here. Let me. So it is, if you can check my new screen or my new window, you can see those asterisks. So I want you to create a diamond shape using asterisk symbols. Am I clear, class? So I've given 2 assignments. Number 1, your program should be able to read what the users entered and then print back to the monitor what the users entered. Then number 2, create a program that, or write a program that generates a diamond shape using asterisk symbol. A diamond shape using asterisk symbol. So those are the 2 assignments. What I want you to do is, once you write your program, you copy it in Word, and then you print screen. Let's see. Once you run your code, you will have this black CMD. I want you to print screen. There is print screen on your keyboard, and paste it in Word. So I should see your source code, and I should be able to see your output from your CMD window, the black window. So you print screen. You print screen. So for example, if I print screen, let me print this. I come to window, to Word. Let me come to my Word. I open a blank page, and then I paste. So let me stop presenting. Then I can present now. The window. You can see that I printed the screen of this, the CMD, and I pasted in Word. So the same thing, you paste your source code, you just copy it. You just copy it from your code blocks. So let me show you. You just come here, you copy. Once you copy, you paste it here, then underneath, you come and print screen and paste. So let me share again. You can see this window. I have copied my code and I've copied the output. So I want you to send your source code and your screen. Of course, indicate your registration number only. The name of the file, and of course you convert into PDF. You can send Word or a PDF, whatever way, but I could love if you do it in PDF. You save as a PDF, you can come here, file, save as, say desktop, and you, instead of Word, you can say F17, whatever. Then here, instead of Word, save as type, you save as PDF. So you save as PDF, and you see now I have that PDF here. So the PDF is what you send to me, but save it, use your registration number to save. Yeah, what Magoma, yeah, it's a screenshot. That's what you are saying, yeah. Okay, where do you send to? Send to this email. My email. Are you in the E-class? E-class of the university? You can be able to access the E-class of our university?
We've never used it.
You have never used it? Okay, so
Yes.
you can send to my email. I'm typing it down. That is my email. You can send it there. Once you complete those 2 assignments, you can send it there. Any question, class? So programming, you have to...
Yes.
Yes, question?
I didn't get the first assignment. Kindly could you repeat? I'm sorry.
The first assignment is this. Write a C+ program that prompts the user or that tells the user to end a sentence. Then your program should be able to read that sentence and print to the screen. So if the program tells me to enter a sentence, I say, I am a first year, it should be able to read that and print, I am a first year to the screen. Is it clear?
Yes. And also, how are we, since there are 2 assignments, we'll give 2 separate files?
Yes, you give
one?
two separate files, or you can use one file, but say, give different headings, assignment 1, then assignment 2. Actually, give one document, but say assignment 1, you put the source code for assignment 1 and the screenshot for assignment 1. Then go to assignment 2, source code for assignment 2 and screenshot for assignment 2. Is it clear?
Okay.
Rather than several files.
Yes, it's clear.
Good. Any other question?
Excuse me, sir.
Yes.
Hello.
Yes.
I was having some issues. I'm Godfrey.
Yes.
I was having some issues with internet connections, and I don't get clearly what you taught on program day. Can you summarize it briefly?
I can't give a summary right now. Once I've done, it's better class you understand me. Once I've moved from one lecture, don't take me there. So kindly inquire from your fellow friends what we discussed last time. And then once you understand, then do what they are doing. Kindly don't take me back. I have a lot of work to do. It's 1 week down the line, and you're trying to inquire right now in my next class, which is wrong. When is the deadline? I give you 2 days. So today is on Wednesday. So you submit by Friday. Deadline for submission, Friday. For submission. Friday at 12 p.m. Deadline for submission Friday at 12 p.m. I think I'm clear. So struggle and do those assignments, send them. If you finish earlier, you can send. I look at them. Josephat, what kind of sentence? You know, now you are telling me to teach you grammar. Sentence, you don't know what is a sentence. I don't think I can do that. Sentence, you know what a sentence is. A group of words is what I'm calling a sentence. So guys, all the best then. If there is no further questions, so do those assignments, send it to my email I've given, and we will be good to go. We'll be good to go. Why are you asking my phone number? Phone number the class rep asks, but it's not very significant. Just do the assignment and send to my email. All the best, guys. We can meet next week.